Welcome to Chemistry Simplified. Our topic for today is Lewis acids and bases. In our first presentation for acids and bases, I mentioned that there were three definitions for acids and bases, and I only talk about one of them, Arrhenius' definition and the Bronsted-Lowry's definition for acids and bases. So today we're looking at the last definition, which is Lewis acids and bases. According to Lewis, an acid is an electron pair acceptor, whereas a base is an electron pair donor. So Lewis' definition is a lot broader than Bronsted-Lowry, which was even broader than Arrhenius. So according to Lewis, any electron deficient atom can behave as a Lewis acid. We haven't talked about Lewis structure yet, but in future lecture we'll discuss that in detail, where I will explain to you what do we mean by electron deficient. Let's look at our first example, HCl. In this example, I put the chlorine on the left and the hydrogen on the right. Normally it's H that is first. And you see we have a little symbol on top of the chlorine, which is the Greek letter delta with a negative. The negative symbolizing that the electrons are closer to chlorine than they are to hydrogen. Why? Because chlorine is a lot more electronegative than hydrogen. And the hydrogen is carrying a partial positive charge, which is the delta. Even though this is a sharing of electrons, this is a covalent bond, but the electrons are not being shared equally. Chlorine has a greater pull on the electrons than hydrogen. Why? Because we said chlorine is more electronegative. So that's a Lewis acid. If we were to combine that with ammonia, NH3, that would be a Lewis base. Why is it a Lewis base? Because it has an unshared pair of electrons that it can give away. This electron here, this pair of electrons. So because ammonia is able to give away that electron pair, so it's said to be a Lewis base. And HCl, hydrochloric acid, receive that pair of electron, so therefore it's an acid because accept the electron pair. And this is the end product. Example number 2. Now let's say we have this structure here, boron trifluoride. So fluorine is the most electronegative atom there is. So it is assigned to partial delta negative sign to say that the electrons are closer to the fluorine than they are to the boron. And boron receive a partial positive charge. So this is a Lewis acid. If we were to combine that with ammonia, the ammonia would be a Lewis base. Why? Because it has an unshared pair of electrons that it can use to donate. So this is the reaction. So boron trifluoride is a Lewis acid and the ammonia is a Lewis base because ammonia is giving away its electron pair. And this is the product. Last example, example number 3. Let's see, we have iron 3 bromide. So bromine is more electronegative than iron. It received the partial delta negative sign, and the iron received the partial positive sign. This means that iron is electron deficient. So this is a Lewis acid. If we were to react that with bromine, Bromine has excess electron that it can donate away, so it can function as a Lewis base. Let's say we take two of these electrons, right? We give them away. So bromine is giving away the electron pair. It's a Lewis base, whereas iron 3 bromide is accepting the electron pair, so it's a Lewis acid. And that's what we end up with. This is the end of our presentation. We hope you found this to be useful. Please remember to like, subscribe, and share, and use the comments section to let us know if you had found the presentation to be useful. Thank you. Have a great day.